In this video, I am describing the shorthand approach to creating truth tables for compound propositions. Here we have the compound proposition we've been dealing with in other slides. P or Q implies the negation of R. And instead of creating a bunch of columns for each compound, for each atomic proposition and some sub columns for sub propositions and a final column, I'm going to show a way that is often convenient for creating a truth table that describes the truth value for the proposition without creating a bunch of uh, other columns or using a table approach. We're still going to need 8 rows in this because we do have 3 atomic propositions, and 2 to the third power is 8. So I'll start by putting down all possible truth values for P, Q, and R. And we had said that we do the first atomic proposition, the first half of the values will be true, and the second half of the values will be false. And then next atomic proposition over, we repeat that or twice as fast, so it's going to be true, true, false, false, true, true, false, false. And then for the third compound proposition, and the last one in this case, we alternate between true and false every line. True, false, true, false, true, false, true, false. And now we use the precedence of operations to decide which ones to calculate next. And that's going to be the negation of R. So the negation of R is just the opposite value for each. So if R is true, then the negation of R is false. And we just write that underneath the connector. And if R is false, the negation of R is true. So false, true, false, true, false, true, false, true. Now let's look at the disjunction. Remember that a disjunction is true when one or the other or both are true. And we can see that that's correct for the first 6 of these. So this will be true, 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 true. And only at the bottom, where they're both false, will the disjunction be false. And now for the implication, we are using this column as the hypothesis, the column underneath the disjunction, and this column as the consequence. And we'll write the result of that under the implication. Well, for an implication, when I'll go ahead and erase my little markings up there. I'll go back. So for implication, true implies false. Well, that is false. And true implies true. Well, that is true. True implies false. That is false. True implies true. That is true. True implies false. That's false. True implies true. That's true. And for these last two, we get the vacuous case because it doesn't matter what the consequence is if the hypothesis false is going to be true. And then we circle the final column to show what the values of the compound proposition are. And if you'll compare this to the truth table on the slides, you'll see that they are identical. And this is the shorthand way for creating a truth table for a compound proposition.